if you go to our CARTI projects page, there is a little area in that projects page that will host the videos. So if anyone you know would like to see any of the recordings of the Seaweed series later on, we have that web page set up so we can host a bunch of those as we go, and you can kind of see them all in one place. Today we're joined by Dr. Jorunn Skjermo. I hope I'm pronouncing your name correctly. I'm terrible with names. And she's going to be presenting to us from Norway about seaweed as salmon feed, or her polychetes project that SINTEF has going on in Norway. So I hope everyone's excited to hear from that on their early morning, early Valentine's Day morning. So I'm going to hand the microphone and the video straight over to her now, and we'll get started with the presentation. It's going to be about 15 to 20 minutes long, followed by some questions. So just hang out, have a listen, and we'll get to some questions at the end. So I'll hand that over to you now.
Thank you. Thank you, Logan, for this invitation and for this opportunity to talk a bit about what we do at SINTEF, seaweed and seaweed research. I will share my presentation and hope you see it quite soon. Now I guess you see it. And yeah, so my name is Jorunn Skjermo, and you pronounce it quite well, I think. So I work as a senior scientist at SINTEF, and I'm a biologist. And just to start, I will just have a couple of slides about SINTEF, because I guess you don't know what SINTEF is. But this is a research institute. It's one of the biggest in Northern Europe. It's independent, and it's also organized as a non-profit company. So we do contract research for all kinds of customers, and we are very multidisciplinary, so we work in very many different types of technologies. So these pictures you see from the marine environments, but we also work with a lot of other things. You can find us almost all over Norway, but we are based in Trondheim, which is in the middle part of Norway. And I also put in the globe here, so you can see where Norway is, because we are close to the polar areas here in the really northern part of Europe. The seaweed research that we have done in SINTEF, we started about 15 years ago, and we have seen a very steady interest in seaweed farming, both in Norway, in Northern Europe, and also other parts of the world. And now the very recent years, there have been several reports on how this industry should develop, that there are a lot of potentials and opportunities in this. And now they call it a seaweed revolution. And this is because it has so many good characteristics, this seaweed. It can be used for so many different things, also for carbon capture and as a climate positive mitigation action. So there are really many interesting things about this now. If we look more to the global and how this industry has been developed for the last 60, 70 years, it has been a tremendous development for the last 10 to 20 years. And as you see from this figure, almost everything that is produced now is from farming, whereas there's also some wild harvesting. So, for instance, in Norway, we have been harvesting seaweed for quite a long time, but now we are also getting more and more into farming of seaweed. And globally, around 36 million tons of wet weight, and that is quite a large number in fact, or biomass. Some numbers from Europe, and also a map showing that there is a lot of activities in, for instance, in the British Islands, in France, also in other parts of Spain, Norway, and Denmark. So, and the production in Europe is still very small compared to what's done in China and other parts of East Asia. But I think that in 2022 we produced 400 tons wet weight in Norway, and this year I think the farm are aiming for more than twice this. So it's upscaling, and this is growing quite fast now. So the use of seaweed, I don't know how much you use seaweed yourself, or if you have many farms there you are, and if you can buy a lot of seaweed products in the shops. But for instance, in Norway, there is almost no seaweed products in the supermarkets yet. So as you see from these pictures, these are from Korea, and it's also some cosmetics here, because it has been, it's also popular to mix some extracts into the cosmetics. But food is the major product, mixed into food, or extracts from seaweed mixed into foods. But we also see a very strong interest for using it as feed. For instance, in Norway, we have a large salmon industry, and here we are really starting to look into more new feed resources now. And we can't use seaweed directly as a food or as a feed for salmon, because seaweed has a very high carbohydrate level, which is not good for the salmon. It also has a lot of minerals, and it has quite a low content of proteins. So and very low levels of fat. So in a way, it's not a very good source for salmon feed. But we can maybe use it some other ways. We can, of course, extract proteins from it and mix that into salmon feed. But we could also use it some other ways. So I will show some results from some experiment that we did a couple of years ago. But first, just some pictures about all the species that we are working on in Norway and Northern Europe. It's most interest in the sugar kelp and wing kelp, because these are fast-growing and large biomass producers, and they're quite easy to cultivate. So most of the farmers that start up, they start with these species. Those is also very interesting. It's hard to cultivate, especially in the sea. So there is no commercial farming in Norway of this species, but I know that there are some other places in Europe where this is produced. And then we have also this Porphyra and Ulva that is also interesting. So yeah. But the kelps are the most interesting ones. And this is just a glance over the competence we at SINTEF have on these things, on the project types that we have. We're working on both the land and sea cultivation of mackerel, mostly sea cultivation. We're looking into integrated multi-trophic aquaculture and climate solutions using seaweeds. Ecosystem modeling, multi-use of ocean space, for instance, together with windmills, recycling of nutrients, and product design, automation, and machine vision. And here are some pictures from when we are cultivating. So we are working a lot with this twine seeding, where we have seeded the twines, which are on spoons. We have seeded them with spores, which are attaching to these twines, and they start to germinate and grow into very small seedlings. So at this picture, I think they are about 3-4 millimeter long, and they are more or less ready to be deployed out in the sea farm. And then we transfer this twine over to a thicker rope. We have some machines doing that work for us. And we take this thicker rope and deploy into the sea. This is normally done during the autumn and winter time. And so this is from an experiment that we did outside here. in quite exposed conditions. And in June or May, or it could also be as early as in April, a bit depending on where in Norway you are, you would start to harvest. And as you see, it's a very beautiful biomass. It is at this time of the year, it hasn't got any biofouling yet, so it's a very high quality for use as food, for instance, and also for other more delicate applications. IMTA integration with salmon farming is of course interesting in Norway with all the salmon farms that we have, and we also see that it's interesting for having more biomass because the nutrients or the effluents from the excretion products from the salmon that is released into the water that increases the growth of the seaweed quite well. So we get more than twice as much biomass by integrating this quite tightly. And this is also, in a way, a way of using the space better. So this is both multi-use, but it's also a better use of the resources, the feed resources that are used for the salmon farming, because the nitrogen that are in the protein that the salmon eat, that will be released, and that is a very good fertilizer for the seaweed. Okay. So we see some farms doing this now in Norway. So here is more about the salmon. How can we use seaweed to feed the salmon? And as I said, it's not good to do this directly. So then we have to look some other ways. So I have to use this very good biomass that we can produce so large amounts of. And we have started to look into polychetes, how they can be produced, and how we can try to upscale polychet production. It is a brush worm that you see on this picture, and normally it eats almost everything. So, but it's not easy to cultivate, but especially if we are going to do it in really large amounts. But we are working on how to control the life cycle so that we get them to spawn and that we can start have a full control of the life cycle. And then we need to develop production systems for them, and of course they need some feed. They also need a diet, and we think that sugar kelp could be a very good source for that. And maybe not this beautiful spring kelp, because that is more for food. But the summer kelp, when it has got a lot of biofouling and can't be used for almost anything else, then it could be used for these guys. And we see that there's also an increasing interest for this, because we need these new protein sources for the salmon. So we started a project on that, and here are from the setup. First, we had to test whether they were happy to eat the kelp at all. And also, when we are cultivating kelp, everything is harvested more or less during a few weeks in the spring or summertime. And we have to store it, because we can't, if we are going to feed it to the polychetes, for instance, we can't use everything at once. We have to store it somewhere. And we think that acid preservation, the kind of ensiling of the seaweed, is a good way, because that is not consuming a lot of energy, and it keeps the biomass stable for quite many months, maybe up to a year or more if we need that. So that's where, in this experiment, we wanted to test both whether the kelp was eating the polychetes were eating the kelp, and whether they were happy to eat it when it had been ensiled or acid preserved. And we also looked into have it affected the growth and the chemistry of the polychetes. And if you look at this video, you can see some of these polychetes in this experiment. So here they have got some particles or some fragments of acid-treated kelp. And you see that they are they are sniffing around and are a bit just doing some studies of what we have given them. And suddenly you see that this is good. I will take one of these bites and take it with me into my little cave. So you see both these two that are left now. They just hide and take this kelp with them. So this shows that they are very happy about having this as a diet. We looked into the growth, and we saw that when we also used the fish feed as a control feed here, because we have to compare this with something. And of course, it's ridiculous to feed polychetes with fish feed and then use the polychetes as a feed for salmon afterwards. So that's not the reason for doing this, but it's more that we need to have some standards to compare with. And we saw that the polychetes they grew, they eat this and they grew. It was not a very high growth rate, but still this is a good start, I think. We also saw that the lipid content was quite good. It was not as high as the control, but still we are very satisfied. And we also saw that they didn't mind if the kelp has been treated with acids before. And the same also for the amino acids. So these are quite interesting results. We also looked into the fatty acids, and for instance, for salmon, we are especially interested in the omega-3s that you see to the right here. And we see that they get more or less the same fatty acid profile as the polychetes that had eaten fish feed. So this is also very, very interesting, we think. So this we hope to work further on now. This was in a way a quite preliminary experiment that we hope to continue in some other new projects. I just wanted to before I finish now, I just wanted to talk a bit about the biomass production and the CO2 capture potentials in seaweed biomass, because we have started several new projects on that, and we think this is a very interesting area, because we really need to do something with all the carbon dioxide in the atmosphere. And as you see here, it has a quite good potential for capturing CO2 from the seawater, and then it is in equilibrium with the atmosphere. So the more we produce in the water and remove, the more CO2 will be dragged into or diluted or dragged into the seawater and into this biomass that we can do. So so this is why we're going to do this, why we're interested in it. We need to use also the ocean to remove CO2. This is a report from the UN high-level panel, so they should know what they are talking about. And so here we see some maps. So this is we are using mathematical models for this to see where are the best sites for doing seaweed farming and how much can we cultivate there. And this is very important for the biomass production. You see the dark spots here. That is where we have the highest productivity, maybe as much as 200 tons per hectare. That is quite high. Inside the fjords, we are much lower, maybe down to 50 to 70 tons. And also for the CO2 uptake, that is of course very correlating with the biomass production. So we see that if we want to cultivate seaweed for CO2 removal, then we can find some spots, some places where we will have a quite good effect from that. Here's also just an illustration of how much area we would need to make Norway carbon neutral through seaweed farming. So 20,000 square kilometers just outside the coast it's a really huge area, so it's not realistic to do this in one farm, but still, it's just an illustration. Yes, so these are the two last slides, I think. What if we are going to have some impact from cultivating seaweed for us as a CO2 capture and removal mitigation? Then we need to do something with the biomass. We can't just feed it or eat it, or then the CO2 will be released again. So then we have to have some methods for that, and some solutions for it. And one is that we are working on is to sink it to very deep bottom areas in the ocean. We don't know about the effects on the seafloor ecosystem, so this needs a bit or quite a lot of research before it can be done in large scale. But we have started to look into this. Another solution is to produce biochar from it that can have some applications, for instance, as a soil improver or water cleaning or something. Yeah. So this is also a very interesting application, and with some quite large potentials. So I think I will. Yeah. So of course, seaweed CDR. This is something that will come in addition to feed and biorefinery and other nice applications. But I think that was the last slide I wanted to show you. So I can stop sharing.
Fantastic. Okay, thank you so much for presenting. That was amazing. That work is on the polychete work is really cool, I think, and being able to utilize the kelp and then move it into the salmon industry in that way, I think is like a really cool idea, really innovative for the work. So I'm going to open the floor for questions. So if anyone has any questions, please just use the little raise your hand icon. Should be across the top, just looks like a little hand, and I'll invite you to ask away. Oh, we got a lot of questions coming in. This is great. Okay, Majid, I think I saw you with your hand up there. So how about you start us off?
Thank you. Appreciate the presentation. It was lovely to hear the progress and the updates on the study. We're actually working with a partner in Birkenes, close to you guys on the west coast, a company called Viking Aqua, and they're I believe the largest land-based salmon operation. They're just moving all their salmon from the ocean onto land-based systems, and we're replacing about 15 square kilometers of their sea pen property into seaweed farms. So I would love to connect you guys and have a follow-up conversation with our partners out there with you if you have time in the future to discuss the, well, if you guys need to expand sites, they have tons of ocean space that they're already licensed for growth, but also as they develop their land-based operation, we are looking into fish feed solutions. And like you said, we have to combine it with insect protein and other things as well. So I just thought that might be a cool connection to make between you and our partners in Birkenes. I'll reach out to you through email if that's okay, but I just wanted to kind of introduce them. So.
Thank you. That would be great. Yeah, thank you.
Beautiful. Thank you.
Cool. Thanks, Majid. Myron, I see you with your hand up there. Ask away.
Sure. Hi there. Good morning. My name is Myron Roth. I'm with the BC Ministry of Agriculture and Food, and that was a really fantastic presentation. So thanks for that. I was wondering if you can go back to one slide that really piqued my interest, and it was a slide where you showed the sort of like it was like almost like a satellite image of the coast, where most of the water sort of more offshore is red, and then it's kind of white, really close into shore. I was wondering if you can explain that a little bit, because I just want to make sure I understand what you're depicting there and how that image works. and how you captured that image. I guess my concern is that I'm getting the impression that what you're showing is there's much less CO2 really close to the shore, but yeah, that one. But it gets darker and darker as you move out, and I guess I guess the question is, the seaweed's there and it's capturing carbon, but how much do we know is actually sort of coming off and then getting back into the environment? So it's kind of cycling around, and the concern is that seaweed is capturing a lot of carbon, but it's also releasing a lot of carbon unless it gets locked away in the deep sediments like you talked in the future slide. In fact, actually, if you could go to the slide one more below, is the one that really captures what I was looking for. Yeah. That one there. Can you explain that a bit?
Yeah. So this is what's captured in the seaweed biomass, and there's also some calculations here on how much that is released, because as you say, there are some fragments and particles and also dissolved carbon that is released from the seaweed. So that is also taken into account here. But we don't have very good numbers for that yet. So that is something that we are working on to try to improve this model by adding data from field work and things on that. And also the reason that we see that the biomass production and the CO2 uptake is much better if you move from the coast and go more into oceanic waters, is because we have longer periods with stable nutrient concentrations out there. So we also have high nutrient levels very close at the coast and in the fjords, but it's used up very quickly. So that's why the seaweed will have a better condition if we can move it further offshore in a way. You can also see that there are some spots inside the islands, and they are high in nutrients because of the special coastal currents that are there that are mixing the oceanic water, the nutrient-rich water, into these areas. So these grounds they are famous fishing grounds, and they are very good, high productivity.
This
there.
is provided
and
by
also some upwelling places.
Oh, okay. So if I had the TV on, it would.
And also the temperature is more stable and low when we go more away from the coast. And for instance, for kelp, for sugar kelp, it's very critical if we are reaching temperatures that are reaching up to 20 degrees, and that can happen, of course, in the in more shallow areas and more closed areas, but out in the ocean, it's never more than 12, 15 degrees. Here.
Okay, thanks. So I guess what this then shows, looking at it closely, is you're getting better uptake as you move further away. Is that right?
Yeah. Yes.
Yeah. Okay. Great. I had it backwards. Thanks.
Yeah.
Cool. Thank you, Myron. Jackie, it looks like you have your hand up there for a question, and then we also have one in the chat. So I'll get through the people with their raised hands, and then I'll get to the question in the chat.
Good morning. Can you hear me okay?
Yeah.
My name is Jackie Dexter, and I am a hopeful seaweed grower in Washington State, US, holdfast mariculture. And my question is, have you found that the salmon farmers are finding that the seaweed is supplying enough omegas and it's transferring enough into the salmon meat? Or are they having to supplement with omegas as well with the seaweed?
Mm. No, it is because the fat level in seaweed is very low. It's only 1% of the dry weight, so it's really it's a very lean plant. So it's not a very good source for it. But when you look into the fat or the lipids, then you can see that it has a very good profile. It has the fatty acids that the salmon needs. So the profile is fine, but it's too little to be a very good source for the salmon. So in a way, we need to upgrade it by using it as a diet for some other animals, insects or something, or polychetes.
Awesome. Caitlin, it looks like you have your hand up, and then I'll get to Anne after that.
Yeah, thank you so much for this presentation. It's been great. I have a couple of questions. The first question is going back to one of the figures where you've mapped out kind of where the ideal locations are for cultivating kelps. I was wondering if that parameter is based mostly on nutrient availability and temperature, or is there other things that you're considering in that map?
Yeah, it is in a way. It's an ecosystem model. So it takes all both the physical and biological parameters into account. So and we also are improving it by adding more and more data about the seaweed, the kelp itself in this. So now we call it a kelp model. It used to be a more an ocean model, ecosystem ocean model. So we're taking away all the parameters that we have available that is used in this model. And So, but what we see, what is has most impact on the kelp, that is the nutrient, of course, light, and the temperature. So, and that's what's having the strongest impact on how fast it grows.
Thank you. And when you're thinking light, are you thinking like light limited, or are you thinking too much light?
Yeah, it could be both. But of course, depending on if we are cultivating up in the really upper water layers, there can be too much sunlight at some times of the year. But I see that most of the farmers, they cultivate from maybe 0.5 meter or 1 meter, and even a bit deeper, and then there's normally not a problem. But of course, it can be too little light. So if we go down to 10 meters, then it will start to get too little light.
Thank you. And then I was wondering if you did any research on kind of like the optimal density, where you're minimizing intraspecific competition, but you're also maximizing biomass, and if you found any results from something like that, or just anecdotal observations.
Yeah. So do you think about the density of the farms, or the
number of lines per hectare, for instance?
Yeah. Well, we haven't, but in a way we are doing it now, because we are about to scale up now. So we are setting out 2 farms, and so then we have to look more into this. And but I don't have a very good answer at the moment. But of course, this will be very important, I think, because we see that there's competition now for the space in the ocean. There's a lot of activities there already. It's aquaculture and fisheries and tourism and both traffics. So it is. So we see that it can be hard now to get licenses for cultivation. So then to have this more space efficient as possible, that is very important.
And about kind of scaling up, is there any environmental effects that you're kind of concerned about, like alteration of water flow, increase in parasites, or is there anything that you're looking at with that?
Yeah, we are looking into invasive parasites and also the possibilities for diseases to develop, because when we are going to have very large monocultures of one species, there is a risk for development of diseases there. So we are looking carefully into this now, and that is also something that we start a project on now. But there has. I think that the farms that we have had, at least in Norway so far, we haven't seen any harmful effects on the environment. And we also have that situation that you're growing the seaweed during the autumn, winter, spring, then we harvest everything. So then during the summer, the farm is empty, and then so it has also a kind of a time for as a rehab
Recovery.
restoration period. Yeah. So recovery period. Yeah.
Thank you so much.
Yeah.
And I guess just I don't know, I know you're not doing like red seaweed and green seaweed as much, but is there any kind of like differences in the cultivation strategy between the kelps and pyropia and ulva?
Yes, I think for the pyro, this nori species, I think it's most probably it will be produced in tanks. I think I haven't seen anyone in Norway trying to do this at the sea at least. So I think that will be tank-based, land-based in tanks, and the same with ulva. But we have done some trials on ulva, and we'll see that we are also able to cultivate that in the sea. But for those, I think at least in Norway and also many other places, we have very good conditions for doing sea or cultivation in the sea. So what we are working on, that is to try to develop the methods for that. I know there's already ongoing cultivation in tanks, but we are looking more into how to do it in the sea.
Mm-hmm. Thank you so much. That's all my questions.
Okay, fantastic. Looks like we have one more hand up. So hi, Anne. I'll invite you to ask your question. And I think you're still muted there, Anne.
Sorry about that. Anne Oven, Ministry of Agriculture and Food. Question for about the palatability of the polychetes. I know that in some studies where they were trying to do bioamplification with feeding seaweed to soldier fly larvae, they had some palatability issues, particularly not so much for the soldier fly, but for the salmon that were meant to be eating the feed made out of the soldier fly. So I'm just wondering whether or not you guys are, or whether that's in your scope to do palatability studies with the polychetes and how that's going.
Yeah, I think as long as you feed them with kelp, it shouldn't be a problem, because that can be traced very well where it has been produced and everything. But we have also done some studies, for instance, with digestate from biogas production, some remainings that you can have from when you're producing biogas. You will have at this digestate, and that is quite nutrient rich, or at least rich in nitrogen. So it can be a good protein source. And so we have done some experiments with feeding polychetes on that, and they are happy to eat that as well. But then we have this problem, this regulatory problems, because we don't know if there are heavy metals or can be some pathogens or toxins there.
My question was a little bit more about the palatability of the salmon consuming the feed made with those than the polychetes themselves.
I see. Okay. Yeah, I misunderstood. So it hasn't been produced enough yet to be used in salmon farms experiments, so salmon feeding experiments yet. So it's too small scale.
Okay, that's fair. Yeah. Thank you.
But I think what we think is that that shouldn't be a problem, because it is it's a marine organism, and it has a lot of protein. So and we can always, I think that the feed pellets that the salmon are eating, it contains a lot of attractants in other ways. So it will probably work quite well.
Thank you.
Fantastic. Thanks, Anne. We have two more questions in the meeting chat, so I'll quickly go through those. The first one is from Jessica. She asks about using acid to store seaweed. So why acid instead of freezing the freshly harvested seaweed? And does the freezing and thawing process damage the nutritional content of the seaweed?
Yeah, in fact, it can, because when you're freezing it, for the first, it's about the energy that you need. So you need more energy to both to freeze it down, and also you need to store it frozen. So that is energy consuming. So that's one of the things. And also when you are thawing the biomass after, when you're going to use it, it will leak out a lot of liquid from the biomass then. So you will lose a lot of water or liquids from it. So, and that's maybe not something you want. Maybe you want it, but at least there is a risk that you are losing something that you want to have there. So I think that is the two most important reasons for not freezing it for a large scale storage, at least.
Fantastic. And then our last question that we have here is from Leslie. She asked, can you explain what biochar is and how it's used?
Yeah, I was very quick on that because I saw the time was running. So biochar is made through a process called pyrolysis, and we are using quite high temperatures, 400 degrees or maybe up to 1,000 degrees, and no oxygen, so that the carbon in the biomass is transformed into a very inert form. It's into biochar, like this, the black char, like you see. And the idea here is that this will not be further digested or by bacteria or fungi, so it's very stable. So it will keep the carbon stable for hundreds of years or maybe 1,000. So that's the idea.
Awesome. Thank you so much. And I don't have any more questions in the chat or any more hands up. So I think that we will end things there. Thank you once again for joining us and presenting on your work. I think that's super interesting that you can transport those lipids from the kelp to the polychetes, and then that could be used in the salmon feed. I think that's super cool, and it might be really something that we could look into on this side of the planet, and something else that we could do with our kelp over here, especially because we also have a good number of fish farms as well. So I think it's a really cool link that we also might have. Hopefully, maybe there's someone in the team's meeting here that could be interested. Majid, you're kind of, on top of all those cool things, so you never know, might be something you might be doing next. But yeah, I think that I'll end everything there. Thank you once again. Thank you everyone for joining. And just a quick reminder that if you know anyone that's missed the meeting, it will be hosted on our website, the NIC website. So just feel free to send them there. And we do have a couple of meetings coming up in the future. I believe next month is also the 14th of March. I think it's going to be more in the afternoon because we have a guest joining us from Australia to hopefully talk about blue carbon and how that can apply to your kelp farm. I think that'll be super cool. So please tune in next time, and thank you once again.